Good morning. My name is Kaman Veti, and I'm going to recreate my earlier solution to Advent of Code 2024 Day 2. I did that in bed with an Android tablet. I'm going to use the same version of Emacs and Emacs Lisp here in this recreation. So the first thing I have to do is aoc2024 is the naming convention I use for the files. And I have a handy dandy little function that I wrote that's in my .emacs file, to which I give the year and the day and tell it to insert, and it inserts a template, uh, which is the file that I'm going to end up changing. So let's look at day two's problem. This is something having to do with the nuclear power source. I think. Okay, I don't remember where I got that impression. Anyway, we have these things that they call reports. Each line is a report, and each report has a bunch of levels. And the historians are asking us to determine which reports are safe. Um, and the rules for whether or not they're safe uh, are that they are either all increasing or all decreasing, that is the numbers on the line, or the two adjacent levels differ by at least one and at most three. So this one was safe. They're all going down and in small enough steps. This one's unsafe because 2 to 7 is an increase of 5. This one similarly decreases by 4. Um, so anyway, so all we have to do is do that. Let's get my puzzle input. And put that in its appropriate place. And emacs eval buffer to evaluate the whole buffer, including the dummy functions for part 1 and part 2. So our job is to fill in this dummy function. So we're going to, as usual, use loop. So the reports are the parsing of the string. So map, no, not yet. The reports are just the individual lines. So we can just say split string, input string on new line. So that'll give us a list of strings, each of which corresponds to one of the lines. And so then we're going to loop, oh, sorry, we are looping already. Loop for report in reports. For levels equals map list. We're going to call the function string to number. Each element in splitting the string, that is reports, and split string defaults to using white space. So that's going to give us the split string is going to give us a list of numbers as strings, and then we're going to construct a list of actual numbers based on that. So for safe equals, so loop. So in order to not care whether we go are ascending or then descending, I'm going to keep the sign, and the sign is going to be set when we see the first one, and then each check is going to make sure that the sign is, that the sign would stay the same. So for level in levels, actually, we want to know the next level too. Oops, that was an unfortunate typo. For level next level on levels, what on levels means as opposed to in levels, on a list means you're going to be returning successive sublists. So you have all of the rest of the elements of the list behind the one that you're, you know, pointed at. And the destructuring on the left, taking that value and turning into two values means you're going to have the first element and then the next element of that, successive sublists. You're ignoring all the rest. And for the very last time, that next level will be nil because you don't have a second thing to destructure. You'll have a list with only one element, and the destructuring will say this is going to be the car of that, but then the coulter will be nil, so you'll get nil for here. So we want to say the condition is that always or null next level. So that means we're at the end and we're not going to be able to do a comparison. Actually, before that, let's say do unless we have our sign, set q sign to sig of next of minus next level. This is minus next level is our delta. Signum returns a -1 or a 1 depending on the sign of that. And that's what we're going to set our sign to. And what we want as our check is that we're always less than or equal to 1 times sign. I should have made this a delta. So it's always between 1 and 3. So if we were making negative, if we're going downwards, then the sign would be negative. So the delta would also be negative. But then multiplying the negative delta by the negative sign will give us a positive number. So this test will work in either direction. It just depends on having gotten the initial sign right. And I think then all we have to do is count. Oops. Right. So the inner loop is returning the fact of it's being safe. That is, every single time through the loop, we met the condition. So then we can just say count safe, and that's the inner loop, the outer loop. So we compile this. And we seem to be having a problem. Okay. We unconditionally are setting delta. I bet you we're at the end. Let's see what our report is. Our levels and our level, the one we're working on. Yes, we're at the end. Uh, so the bug is that this should be and next level, because we can't actually do arithmetic on next level unless we have one. So in anticipation, we got 2. That's what the the problem text told us was the answer. And now we got 326. Let's see if that's the answer. It's pretty simple, so I'm pretty sure it's right. So in the next part, they've changed the rules of what's unsafe. They say there's this special problem dampener, which will consider a report safe if there's at most one uh, entry that causes a bad test. And if you removed that one entry, all the rest would, meet the original test. So, and the answer for the sample problem is 4. So, as usual, what we're going to do is we're going to add an optional argument, part 2. We're going to, here we're going to just call part 1 with input string and t to have that optional argument passed in. Uh, and then we're going to do something slightly different. Um, so this is basically if not part 2, but I'm going to call it part 2. And we're going to do it again and close the if. One cool thing about emacs, Control T transposes the 2 characters before and after the cursor. Meta T transposes the words before and after the cursor, but Control Meta T transposes the regular expressions, whole expressions. Since they're the same, it didn't do anything visible. Um, but so so instead of saying that this condition is always true, what we're going to do is say, well, okay. I solved it this morning earlier in bed, and I forget exactly how I went about doing it. This is slightly embarrassing. Okay, so what we're going to do for part 2 is we're going to count how many failures there are. So let failures start off as 0. No, it's not going to start off at 0. We're just going to count it. So instead of saying that we need always, we're going to count when this is not true. So we're good if the failures are 0. We already done all the work we needed to. If not, we're going to loop again and do this exact same test as here, but we're going to do it on lists. So we're going to say loop for sublist in. We haven't written it yet. So if there are no failures, the initial test, which is slightly more expensive because this would die on the first failure, whereas count has to go through the whole list. So if we counted the failures and there weren't any, we just return true. Otherwise, we loop for a sublist. Actually, what we're going to do is loop for index below length levels. And the sublist is going to be loop for E in E in levels for I from 0 unless equal I index collect E. So we're going down the loop. So we're going to leave out the index, the element where the index is the same as the index in the outer loop. And for each of them, we're going to run the whole test. Um, and that will tell us that minus that one index element, we still meet the safe condition. So first thing is to see, make sure we haven't changed to 326. I think I already compiled this, but it doesn't hurt to be safe. Whoops, well, so we have a bug. That's supposed to be 4. Okay, well, so we get to debug. So first thing, for part 2, we're inside of here. So I'm going to just debug failures for uh, debug can take a string, uh, but there's no reason that that string can't be a format string that you filled in. So failures and levels. So let's go to the sample. 0 failures for nil. That probably means I typed the wrong thing, or levels. That will certainly give us the wrong answer, because if levels is bashed, uh, this won't find any good. Why would levels be nil? I'm not seeing it. So this is before we levels. How can levels be nil? The only way it could be nil is if report were empty. How do we get the empty string for report? It's acting as if these values. I said metax eval buffer after I must have done metax eval buffer when they were empty strings. That would be a blunder, because at defvar, if you evaluate it and it already has a value, um, then we can find that out. But then we wouldn't get the right answers for the first ones. I am confused. Sample. Control X, Control E. Part 2 sample. I have been by that before. Okay. We can step through it. 1 failure. And we do get 4. Silly me. So to get rid of my debugging stuff, another very cool feature, um, this one I can just kill because he's a whole expression that's at a certain place. But this one, because it's inside of a newly added piece of expression. I could say metax kill backward up list, which says take the expression that I'm sitting at the beginning of and hoist it up one, uh, which is again only possible because of the extremely simple syntax of Lisp that Emacs itself can know completely. So, so 381. And indeed, so sorry about the confusion. Hope you enjoyed it anyway. Thanks for your attention.